All right, so today we're going to start our area of triangles. We're going to split this up into 2 days. So the front, we're focusing just on right triangles and acute triangles. So let's first talk about area of a triangle. You might remember this formula already, but this formula is 1/2 base times height. For any triangle, the base is one of the sides, and the height is the altitude to that base. Okay, so whatever you are calling the base, the height must be making a right angle with it. Okay, so I'm going to put that down. The base and the height must form a right angle together. Okay, so make sure of that when you identify your height and your base. So we start off with right triangles, which are very easy because the height and the base are 2 out of the 3 sides in our triangle. So it makes it a little easier to work with. So when I'm looking at this first example, I'm trying to identify my height and my base. So the height and the base must form the right angle together. So if this is my base, I'll label that B for base, then my height must form a right angle with the base. So there's my height and there's my base. Obviously I know the base is 10, but I'm going to need to find the height. And this is a right triangle. So if you know 2 sides and you are trying to find the third, you would have to use Pythagorean theorem. So I have leg squared plus leg squared equals hypotenuse squared. This comes out to the height being square root of 125. And when I simplify that, we get 5 root 5. All right, so now we know that the base is 10 and the height is 5 root 5. So now we can find area. So area is 1/2 base times height. So that's 1/2 of 10 times 5 root 5. And since this is multiplication, the order that you multiply doesn't matter. Just make sure you're not accidentally distributing. This isn't distributing. This is just multiplying 3 numbers together. So we're multiplying 1/2 times 10 times 5, which is 25, and then we still have the root 5. So this area is 25 root 5, and this is squared inches. Okay, so the biggest thing is you're trying to identify your height and your base and make sure your height and your base always form the right angle together. Now, number 2, we are given the area, we are given the base, and we do not have the height. We don't even have a picture. So we know that the area is 1/2 base times height. Let's start filling in everything that we do know. We know that the area is 72, so I'm going to replace A with 72. I'm following the formula, 1/2. We know the base is 18 root 2, and we're being asked to find the height. So in this case, I'm trying to solve for H. So what I'm going to do is I'm going to simplify a little bit here, and I'm going to take half of 18, 18 root 2, because I know that I know what half of 18 is. So half of 18 is 9, so that's 9 root 2. Okay, now if I'm trying to get the H by itself, what would we do? Well, we'd have to get rid of this 9 root 2. So in order to get rid of that 9 root 2, I have to divide both sides by 9 root 2. So now the H is by itself, but I have some simplifying to do because we know we can't have a root 2 in the denominator. So I'm going to multiply top and bottom by root 2. In my numerator, I have 72 root 2 over 18, because root 2 times root 2 is 2, times 9 is 18. And then I can simplify the 72 and the 18. That actually comes out to 4 root 2. So our height is 4 root 2. Okay, on to the acute triangles. Now, with acute triangles, the most important thing is we have to decide where our base is. And once we determine where our base is, then we draw in the altitude, which is going to be the height. So remember, your altitude is going to be your height. So for number 3, we have some freedom. They're actually telling us what the height and the base is. So we're not going to have to do too much work. But the thing is here that this picture doesn't have any of the sides labeled. So we decide which one is the base. So I'm going to say that the base is down here, and that's 12, which means we must draw the altitude so that it makes a right angle with the base. And we just decided that this is the base, which means our altitude needs to come from the vertex across from that base, and it needs to make a right angle with the base. So that's what this would look like. So that was a good example to practice identifying the base and then drawing the altitude so that it makes a right angle with the base. Now we can follow our formula because we have everything we need. The base is 12, the height is 6, and this is just multiplication, not distribution. So 1/2 times 12 times 6 is 36 square feet. All right, now number 4 is a really good problem, so make sure you're starring this one or paying extra close attention. Okay, when we look at this triangle, what do we know? We know 2 of the sides, and we know 1 of the angles. This is really important. Do not ruin the angle that we know. Okay, so here's what I mean by that. I don't want to draw my altitude coming from that angle because I just ruined the only angle that I knew. Okay, so you want to avoid drawing your altitude through the only angle that you know. If you know more than one angle, then it might be okay to draw your altitude through that angle. But if you only know one angle, don't ruin it. Okay, so I have 2 options. I could do this as my height, or I could do this as my height. So basically, I could draw my altitude from the 2 angles that I don't know. Okay, so just to make this a little easier to look at, I'm going to draw it here. Okay, that altitude is my height, and I obviously do not know what it is. The most important question here is, where is the base? The base and the height always have to form the right angle together. So that makes 31 your base. Okay, so we have to figure out what the height is. So what we're going to do is use our right triangle rules, because now I just created a right triangle inside of this acute triangle. So here in green, that is a right triangle. I know 1 angle and I know 1 side. And that 1 side that I know happens to be the hypotenuse of that green right triangle. So guess what we're using? We are using trig. We need to find the opposite side, and we know the hypotenuse. So the side that we know is hypotenuse and we want opposite. So we're going to be using sine. So sine of 42 is opposite over hypotenuse. We have to get the variable by itself, so we're going to multiply both sides by 27, and then this goes in your calculator, and you get 18.1 for the height. All right, so now we know our height and our base, so we can follow our area formula, 1/2 base times height. And we will have a decimal because we had no choice, we had to use trig. So this is 280.6 squared meters. Now, something else I want to point out about this problem is when you were using your trig, when you got to your SOHCAHTOA step, notice I did not use the 31 when I was trying to figure out which trig ratio I was going to be using. And that's because that 31 is this blue segment. It's the whole thing. When I'm using SOHCAHTOA, I'm only looking at this green triangle. So I have to look very closely at that green triangle and figure out which side of that green triangle I know. And it's the 27. That 31 is too big to be a part of that green triangle. So just be careful there.